the recording. So there is one last thing that is left out, that is logistic regression analysis. One second, let me select a pen here. So this, okay, this is the last thing that is left out. What do you do if y is continuous and x is discrete? Yeah, that is the time when you do this particular thing. You look into logistic regression analysis. So let us continue that. Do you want me to wait for a minute? I'm continuing that. So in analysis of y discrete and x continuous, sorry, my bad, I've told the other way around, right? So when y is discrete and x is continuous, you use logistic regression. Logistic regression analysis is used for analysis whenever you have y which is discrete and x which is continuous. By the way, there are three types of logistic regressions: binary logistic regression, nominal and ordinal logistic regression. We will do a deep dive on these data types, what is binary, what is nominal, and what is ordinal data type in your in a master black belt. So these are the two logistic regressions that are available. Whenever you have binary response, that is, it has two outcomes, yes or no. Defect is available or defect is there in the product or no. Yeah, true or false. In such kind of scenarios, you use binary logistic regression. It examines the relationship between one or more predictor and a binary response variable. A response is always y. Binary response means yes or no, true or false kind of things. Right? Predictor variables, another name for x, that's it. It's another name for x. All right, let me erase everything. Ordinal. Ordinal is the relationship between one or more predictors and an ordinal response. Once again, ordinal means they're categorical variables that have three or more levels. For example, I agree, strongly disagree, neutral, all these are your ordinal type of data. Then we also know that there is nominal kind of data. Whenever the data is nominal, we use nominal logistic regression. And these things we will discuss in detail, ordinal and nominal in master black belt. For now, let us focus on binary logistic regression. So this is a function that we need to actually, probably you can by heart this, but it's not mandatory for you to remember everything, right? So this equation. The transfer function of binary logistic regression is based on the logistic transformation of y and works with probability PE. But I mean, this is not that serious that you by heart this, you write down this 10 times. It's not required, right? So let us move on with the actual practical problem. Space Shuttle Challenger disaster. I mean, in 1986, if I recollect exactly, on 26th or 28th of Jan, I believe, there was one disaster that has happened in NASA. They were actually trying to send a space shuttle along with a teacher. There was a teacher who was supposed to deliver the teaching from space. So she was also onboarded on that, and midway it blasted. So later on, when people have analyzed, they have found that there was some problem with the temperature, hence the space shuttle has broken down. So let us discuss this. The input is the launch temperature. What is input? X. What is X in our case? Temperature is always continuous variable. So input is continuous. And the output is O-ring, whether it has failed or not. Yes or no. Failed or not failed. That is discrete. So the output Y is discrete and X is continuous. So you use logistic regression here. So they're asking us to build a model and use it to predict if the Space Shuttle Challenger would fail if the launch temperature was 33 Fahrenheit. Let us do that. So let me actually go to the, so I'm opening the Space Challenger thing. Here it is. Right, so I think fits has come after I've done some experiment here. All right, so temperature is provided, which is continuous. Temperature is always continuous, and this is what your input X. And O-ring failure. O-ring means there will be a ring in the shape of O. I've opened a file called Challenger failure, Anuj, in Minitab. Yes, it is sent to you. Entire thing is zipped and sent to you actually. Right? So O-ring failure. 1 means it has failed, 0 means it has not failed. Simple. Yeah, now let us do this. We just need to go to stat regression. We have binary logistic regression. Let us fit the binary logistic model. Here, response in binary response or frequency format. Yes, response is in binary format. 1, 0 is binary. What is the response? Either my O-ring failed or not. So I selected O-ring. Response event 1. 1 means yes, it has failed. 0 means it has not failed. So that is how I'm selecting 1 here. Then my predictor temperature is continuous. So hence I have put it as temperature. Now I go to storage. I just select this event probabilities fits and then click on OK. So this is the output that I've got. Once again. So this is the output that I've got. We have in total 24 events. If I go here, there will be 24 events. Yeah, there are 24 rows in fact. And there will be 7 ones in this. 7 times it has failed kind of. So that is visible from here. There are 7 7 count which has value 1, and there are 17 entries which have value 0. Now let us go back to the presentation and understand what does that output mean to us. Let me put it in the slideshow mode. All right, so this is the same thing. This is the output. So summary of the event is provided here. We have total 24, 7 entries which have value 1 and 17 entries which have value 0. Now look at this temperature p-value. It's less than 0.05. Hence we are going to reject null hypothesis, or otherwise you accept the alternate hypothesis that we can build a model between temperature and O-ring. Is temperature leading to O-ring failure? Yes or no? Yes, we can build a prediction model for that. Then we look into goodness of fit. P-value for lack of fit is greater than 0.05. You see everywhere it is greater than 0.05. Either use Pearson or Devayans or another scientist named Hosmer Lemieux, right? So hence there is insufficient evidence to reject that the model is not a good fit. Instead, what are you telling? Yes, model is a good fit. I do not have evidence to reject the model. Model has a good fit. That means the prediction model that you're going to use is going to help you. Right. Another thing, what is a summary? All right. So what are we planning to do here? What is the scenario all about? Question. Are you aware of the question? Trying to find out what? They're asking us to build a model and use it to predict if the Space Shuttle Challenger would fail if the launch temperature is 33 Fahrenheit. Right? So this is what we want to do. Now, one second. Let me discard, go here. So this is the equation actually. O-ring failure is equal to 10.88 minus 0.1713 times of temperature. If temperature is 33, just replace 33 here and you'll get some value of Y. So that some value of Y, based on that, we can actually decide whether our space shuttle is going to fail or not. Right? But this simply says that yes, there is a model that exists. You can build a prediction model. That is what this says. Now, if I go to graph and scatter plot, if I put a scatter plot between Y is O-ring failure and X is temperature, if I do this, what's going wrong here? All right, one second. What happened? Let me replace this with OFETs and see. Yeah, here comes this. So this fits is nothing but, so let me go back to this slide and explain here. So this is the probability, right? 0, 0 0.1, 2, 3, 4, 5, 6 until this is probability that the space shuttle might fail. So if you look at the temperature, as and how the temperature increases, the failure rate has gone down. But when the temperature was at its bare minimum, 50 and less than that, your space shuttle's probability of crashing or failure was increasing. So this is 50 Fahrenheit. If I look into 33 Fahrenheit, it will be somewhere here. So at 33 Fahrenheit, there is a high probability that O-ring is going to fail. Is that clear, Anuj? 33 will be somewhere here. If I just take this particular graph to the left side, and the moment I start moving to the left side of this, probability is going to increase. Hence at 33 Fahrenheit, you can be rest assured that it's going to fail. That is what we conclude. So by doing this analysis, we found that yes, there is a model that we can build. There is a model that can exist between temperature and O-ring failure. By using a simple scatter plot, we have concluded that yes, at 33 Fahrenheit, it's really very difficult. All right. Here is a simple quiz. You know, we have come to the end actually of this analyze phase, but here are a few things. Which of the following statements is true? Right. So look at the first one. Correlation coefficient, which is always represented by small r, lies between 1 and -1. Is this true or false, Anuj? Yes, true. The nearer the correlation coefficient is to 0, more is the relationship between two variables. Is this true or false? No, this is false. If r is close to 0, that means there is no relationship between the two variables. Yeah, correct. If it is close to 1 and -1, then there is a relationship. All right, let's look into negative correlation. Negative correlation means the value of independent variable, that is x, decreases as the dependent variable increases. So just simply plot x and y. So this is my y-axis, this is my x-axis. Independent variable is x, always. Another name for x is independent. Y is dependent on x, so it is called as dependent variable. So what are they telling? As the value of independent variable decreases, as the value of x decreases, or sorry, the value of independent variable decreases as the dependent variable increases. So they're telling if the y increases, x is going to decrease, right? Is called as negative correlation. Yeah, Anush? Is this called as negative correlation or positive correlation? Third point. You're asking me or are you just telling me that this is the answer? I didn't get I didn't get the confused. Okay. Then let us see simply. So y increases means these are the y values, right? Suppose the y value increases, x value decreases. That is what they're telling. If x value decreases, it should be somewhere here, right? Or let me take it from here. If y value increases, x value has to increase. For what correlation? As y increases, x increases for positive relationship. Right? This is positive relationship. Or in negative relationship, how does it work? As x increases, y decreases. Would be in this way. Yeah, as x increases, y decreases. That is negative correlation. Now they are telling x increases, y increases and x decreases. So x decreases as y increases. Hence it is negative correlation. All right. Yeah. Next thing, correlation does not determine causation. Is this correct? Correlation does not determine causation. Is that correct? No. Correct. True. No, this is true. I mean, correlation does not determine causation is correct. Correlation determines causation. That is wrong. All right. Regression is used to predict relationship between a discrete and a continuous variable. Is this correct? Is this correct? If y is discrete and x is continuous, then we have used logistic regression. Fine. But we have also used linear regression. When did we use that? We have used linear regression when both x and y were continuous variables. Yeah, exactly. So this is false. Regression is used not just when uh, to predict not just the relationship between discrete and continuous variables, but also to predict the relationship between two continuous variables. Yeah, and the last thing is two-sample t-test is used to determine if there is any difference in variance in two different populations. Is that true or false? No. Two-sample t-test is used to determine if there is any difference in the mean. Mean. Yeah, for variance there will be a different test. It's mean. It's not variance. All right. So this is the last step. Process to narrow down vital few x's. The process for narrowing down the list of potential x's is shown in the figure. And just list all the potential, collect the value, check whether they are statistically significant or not. If they're statistically significant, check whether it meets your goals or not. If yes, those are your vital few x's. If in this decision, if it's not statistically significant, you put it as trivial x, not important at all. Right? If you find that those x's are not going to meet your goal, then what should you do? You should try to identify more inputs. So this is a simple logic flow diagram that you need to remember. Yep. So simple question. This is the target. Whenever we do a project work, you'll have to just focus on these questions. Did you do all these things? Yes or no? For that reason, we have provided these questions. There is no other reason for this. So let us do a quick summary of analyze phase. A prioritized list of all possible potential causes or sources of variation are identified. We have grabbed the data to look for any patterns. We have also tried to identify critical excess inputs by using hypothesis testing, and we have used various statistical tools such as ANOVA, etc. Then we verified whether the vital few x's, which are statistically significant and practically relevant, are sufficient for us or not. And then if required, we refine any financial benefit estimates. Before the project started, probably you told that I'm going to save $1 million, but in analyze phase, maybe you felt that it's not 1 million, it will be $2 million that we are going to save. So you just refine your financial benefits as well. So this is how we actually end. All right, there is one more thing that we can probably do. Let us look at this. Torque is applied in assembly line to tighten PCB. This is some kind of circuit board with the base. Data retrieved from quality department is shown. Find the relationship between input and output. Y is fail or pass. It is binary once again. Yes or no kind of. True or false. 1, 0. So Y is discrete. Torque is always continuous. If Y is discrete and X is continuous, what regression method are you going to use? Anuj? If Y is discrete and X is continuous, what do? We go with binary logistic regression. Okay. Yeah. So anyways, thank you has come. So let us do this exercise also. Okay, I think I have it open. Same thing, we do not do anything more. We just do the same exercise. So what are they asking us to find out? Whether find the relationship between input and output. So simple. Let me go to stat, regression, binary logistic regression. Let me fit a binary regression model. Response variable is in this. 1 means pass, 0 means fail. So I have a continuous variable which is nothing but my torque. I click on store and I'm going to store the event probabilities. I click on OK. Yeah, in all these cases, p-value is greater than 0.05. Hence you say that yes, a model exists. I can build a model. Yeah, and also if you see, here is the equation. They're asking us to find the relationship between X and Y, right? So let me see whether I can put it here. Yep. So this is my final equation. I'll simply say that my result, whether it's going to fail or pass, is going to depend on this equation times of torque. Yeah, Anuj, is that clear? Yes. So we are going to build this kind of a model. So that is all about your regression. Yep, we are done. We are done with the analyze phase.